We often need to do a series of calculations that involve a normal distribution or any continuous distribution. Excel has a built-in function for doing the quick percentages, for getting the actual value of the normal curve out of the function. But you often are in a position where you've got to create a small little spreadsheet of a series of values to do that. So it pays to have that kind of spreadsheet pre-built, kind of in your toolkit, in your library as you go through. So I just want to go through and build one right now. You should do the same thing, both to demonstrate how the functions work and to give you an idea of the kind of logic you build into these kinds of spreadsheets. So for a simple normal distribution calculator, I need to know my x bar value and my s value associated with the normal curve that I'm in. So let's say I have a normal distribution. I have an x bar of 1,000 with a standard deviation, say, of 200. Now, when I build these types of spreadsheets, I typically take the parameters of my distributions and I do them in red. So I would recommend also that you separate things out and make them normal in that way. So I want to find the probability of a given a value. So let's say the value like 700. And what's the probability around the normal curve for that? When I'm dealing with the property of interest, I usually use a blue color just so I can spot the parameters that I'm entering as I go through. So one of the things I need to know is the z value associated with that a. Okay, so I'll often take that and maybe subscript it in my toolkit to make that work. So I'm going to plug in the property of this table would be the x value I'm interested in, 700, minus the mean, okay, divided by the standard deviations. Okay, so my 700 value is 1.5 sigma to the left of my x bar 1,000. And now that I've got that value, I can actually look up the probability that in essence, any x value will be less than that a value as I go through. And to do that, I can just use the standard normal distribution function in Excel, where I simply plug in that z value, and I get that. So the property of being 700 or less on my standard distribution of 1,000 with a sigma 200 is about 6%, 6.5% as I go through. I might, for completeness on my tool, want to be able to know also the probability of it being bigger than a. That's often what some questions ask, and that is simply 1 minus the probability that I already calculated as I go through. Now, one of the things I want to do is kind of lock in those parameters at the top. The red ones aren't going to move, so I want to lock those in terms of my calculation so I can copy my cells and make that work. Because typically I need to have two sets of data because I'm interested in the probability between two values. So I might be working with a b here. Might have been faster to retype the whole thing, but I'll just go through and change to the b. And suppose I want to go 700 to maybe 900. Okay, so 900 is half a sigma to the left of that 1,000. If I pick a bigger number, bigger than 1,000, it'll go positive. Okay, so 1,100 is half a sigma to the right of that, and here are my probabilities of doing that. Now, often I want to know the probability of my x being between the a and b that I've calculated going through. So to do that, I simply have to add the two probabilities. The tail on the right plus, I'm sorry, not tail on the right, tail on the left, rather, if I could type. Okay, the tail on the left minus the tail on the left. Okay, so there's 62%. So 6% of my data falls to the left of 700, 69% of my data falls to the left of 1,100, and therefore 62% falls between 700 and 1,100. So that's basically how I do my basic calculations. So the values I'm typically interested in is that one, but not necessarily. It could be any. I could be looking at the probability of being greater than b, and that's the 30%. So, but when I have an a and a b, usually it's the probability between the two that I'm interested in as I go through. The other thing I might want to do with a normal distribution calculator is to know the probability of any given x as I go through. So what is the x value, say, associated with a 0.5? So if I do a 0.5, that's a parameter, so I'm going to change that to bolded again. I need to know the z that I want for that x as I go through. So I'm going to subscript that. Okay. To get that calculation, I simply need to know the norm's inverse. The norm's inverse function gives me the where I give it a probability like 0.5 and get back the actual z value that I want. Now it's interesting because Excel is obviously a computer software. It's going to round things off when it integrates that function. So -1 times 10 to the -16 is virtually 0, but I don't get that out of my version of Excel. So if I simply round that to 8 decimal places, I get the number I'm expecting. So then I can come up with the x that I want for that, which in this case is the z factor that I calculated times my s. Okay. I forgot to put brackets around that. So and divide and add that to my 1,000. Okay, so the median, the 50% point in my curve is in fact 1,000, which you would expect. But again, if I were to say the 0.0668 point in my curve, I get 699. So I basically took the probability of A and to reaffirm that 700. In fact, if I take the value of that cell right there and copy it down to here, I actually get the 700 that I was after. So from rows 6 through 10, 11, I can calculate the probability between any two values. Rows 13, 14, 15, I can take any given probability and determine its value. So if I want to know the third quartile value, 75% quartile, the value for that would be 1134. Now whether I round that off to an integer depends on what this data means, so I don't do that kind of cleanup as I go. So this is just a very quick normal distribution calculator. You should have one at your fingertips. If you have this pre-saved, half the time you go to solve a problem involving a normal distribution, all you'll have to do is type values into the red and blue cells in this spreadsheet and you'll have the answer that you want. It simply saves you the time of building this spreadsheet every time you want to solve a problem.